Alright, let's get back into it. I have a new idea for what we can look at, and it's something called Wang tiles. Let me pull up a picture of it. So it's something like this, where you have a set of tiles with different colors or whatever, and they're allowed to match in different ways, like green can match with green. And in this example, but there's also examples like this where you have like some snakes or whatever, and then you can get interesting shapes like this. So that's the goal today, learn about that. And previously I used ChatGPT to get an introduction to OpenGL, which I thought was very interesting. So I'm gonna try the same here, but this time with a bit of I want to try two things. So I want to try a bit of GPT recursion, asking it to improve upon itself, like what the output it has done, try to improve upon that, and also try to get it to output things in like a step-by-step format, because that's supposed to be a little bit better. So let's try that. I want to learn about Wang tiles. Please suggest a list of steps I could take to do this. So let's see what it says. So it suggested a bunch of things, and a lot of them are like review mathematical prerequisites, solid foundation in graph theory, combinatorics and things like that. Study tiling theory, learning about different types of tilings, periodic, aperiodic, hierarchical, and their properties. We are not really going to do all this, although it could be interesting if you really want to develop expertise. We're just going to try to learn by doing. So what we're going to do is perhaps step 4. Learn about applications, procedural generation, computer graphics. That's the one I'm mostly interested in. Image processing, that's also kind of interesting. Computational complexity theory is also interesting. And apparently there's some puzzles. But also number 10, explore software tools. Let's try to hone in on this topic of computational Wang tiling. So write a list of steps needed to write a small program. Let's say Python, because there's most data for that. Small program in Python to construct a Wang tiling. And I have to click. Okay, so it's given pretty good set of steps. Familiarize yourself with Python. Let's say we've done that. Understand Wang tiles. Let's say we've also done that. Define Wang tile data structure. Create a data structure to represent the Wang tiles in your program. You can use a class or dictionary to store the tiles, edges, colors, or any relevant information. Let's actually go to Wikipedia and Wang tiles. So let's try to actually make this data structure ourselves first, before we ask ChatGPT to do it, just for fun. So I've read a couple of books by this guy. Interesting. Okay. So what do we need? Let's say we want something representing different possible, let's say, colors, and then we want a class for a Wang tile, and maybe it has methods like can match. Let's call it can match, which takes self, other tile, and side, and something like that. Let's start with that. So what could we use to represent different colors? Probably an enum. That was amazing. And then let's make something like this. It doesn't have to be colors, but for now let's do something like this. I mean, it can be other things, but in any case, we need to have something representing the different values of each side. Another method we want is like a render, which takes self and maybe it takes an axis. So let's start writing that. So Wang tile, and let's say it takes a bunch of colors like left is a color, right is a color, top and bottom are colors, and let me just do this. It will not let me. Okay, there we go. So that looks good. And let's try this can match. And basically, yeah. We could also imagine having tiles with different shapes. Like for example, hexagons can also tile the plane. And then we wouldn't have left, right, top, bottom. But for now, I think this is all right. And so ChatGPT suggested, so there's a bunch of steps. We're doing this one now, but in the number 9 says we need to render the output, and we can use matplotlib or something. So I suggest we use matplotlib because I'm most familiar with that. And it should have an axis, and that is not correct. So it should be something like plot a square with the colors of the tile on the matplotlib axis. So how do we actually plot a square? Is it like this? Let's look it up. I just realized we need some other things also. We need this exactly. So then what we actually need to plot is 4 triangles. Like if you look at this thing, it's actually 4 triangles that we have. So let's use this polygon thing, and first let's get the vertices, which let's say that x and y is the center. So let's say vertex 1 is x minus size divided by 2 vertex, and actually let's do it like this, and that's fine, that's fine. And then let's say, does it have a polygon? Probably not. Maybe we don't want the axis then. I don't know. Let's try this. Polygon. We need one more. My bad. Which is think minus, well, the third one is just in the center. So it's just going to be xy. And actually, no, that should be fine. So then we need, I can try this. And this is not the top one, this is the left one. Let's make a short test for this. So let's make a tile, which is a Wang tile, different colors, which is fine. Then we will render it and then we will show. And let's try that. It didn't do anything. It literally did nothing. Hello. Ah, okay, interesting. Then we can take the axis. Let's call it X actually. It's kind of like the idiom in Matplotlib. And then let's make something like that. Let's try that. Okay, so it did do something now. I shouldn't need that. So what is the problem with this? Is it perhaps not recognizing this color? Red should be fine. What is that? What is happening? Okay, it's probably this thing that it doesn't understand. So what are they doing here? They're taking the first 3 rows and then I'm sure it's not this, but let's try that. Right, so we need to super it first. It's a bit stupid way to do it, but what? Okay. So is it perhaps something with this? Looks all right to me. What if we also scatter them first? Right, then it cannot do it. It's a bit annoying, so let's call it vertices. Instead, this axis is this y's is that. And then it'll be x's and y's. And okay. So for whatever reason, if you don't plot the points, it also doesn't. So we can do something like this, make it a 0 size to hack it. And I'm noticing it's actually kind of wrong. So what did we do wrong here? Yes, that one. So they're both going to the left, and one should be going down and one should be going up. And this is what I wanted. Yeah. And then we need to say, how is it x is equals? That's the one. And now we have this problem that the sides are not, but I think it's fine. Okay, so this is the left side, and then we have to do that for all of the other ones. So for example, this would be the right side, and this would be the bottom, and this would be the top. So maybe we can, it's a bit weird, but so for example, well, I guess there must be a better way to do it. But I guess if Copilot just fills it out for us, do we really care? How about for, let's call it x sine in -1, 1. No, is that gonna work? Is that gonna work? Then we'll have -1. We will never get minus and plus, so that's the problem. So what is, so let's say x sines is -1, 1, y sines is -1, 1. And then I want to say sine combinations is something like but we're never interesting thing is we're never, there's not one that is minus plus on both of them. So I guess, what do I want to do? So I want to generate a list of things, and it's not this. This is gonna be wrong. Let's just fix it. Let's try that. Yeah. It's doing something a little bit. Okay, I feel like I'm spending too long on this now, but let's say it's not. So what we want is like first to select which side is constant and what is the sign of that side. And yeah, and that's enough. So it's not gonna be a nice list comprehension. So I am inclined to just do that one. Just hard code all the. Let's do that. So for side in, or let's say it's gonna be a list, right? So let's say for V2, and we actually do want to zip with the colors. So, but it's horribly long, difficult to read. Let's, instead of this, let's do for I in enumerate sites. Let's then do this thing. Okay, great. And we always need a constant V3. And the color is then, actually let's then make self.colors is that. Let's delete. Okay, let's give that a try. Fantastic. So there's kind of like a weird artifact. Like it's a pixel off or something, but I guess that's fine. Now we have a Wang tile. Took a while. Let's see what the ChatGPT would say. Explain how to create, how to do step 4. No, step 3. How to create a Wang tile, data structure in a few steps. Okay, so it's provided quite a nice start at least. So it's done the same as us. It doesn't have the match thing. It has something I didn't think about, which is when we do matching, we actually want to be able to rotate the tiles. We didn't call it northwest, east, and so on. We called it. I need to do G. So let's do north and top again. Let's do south, bottom, and east. Left was east, but really it should have been right. And then west is left. Then it has this neat way of rotating things where it just loops. So if we rotate it more than 4 times, it will just go back where it started, so you can just rotate the modulo 4. And then it just rotates it clockwise as far as I can see. because what was left is now top, what was top is now right, what was right is bottom, and what is bottom is left. Rotate clockwise. Okay. It also has this wrapper method, which I am also a fan of. Let's do north, top, east, right, and south, bottom, and west, left. Let's try to print the tile, see what happens. So it prints it like that, which is fine, that's what we wanted. Okay. So what's next? Now we have this, generate a tile set. So let's say, provide a list of steps to generate an interesting Wang tile set. Okay, so let's see what it said. Creating an interesting Wang tile set requires designing tiles in a way that such they can be combined to create visually appealing and diverse patterns. Sure. Decide on tile size. Okay. And then it said something about the shape, which the size doesn't really matter. It's only like relative size that could matter, but we're gonna have them all the same size. Actually, I want to do another thing, which is axis. Can you do that? What happens if we do that? Yeah, so this is what I want. Great. Let's have another one just before we keep going. Let's make one that is blue there, and then let's put it to, this is, what is that? That is, the first one is left, the second one is right. So put that one to the right. So tile 2, render on this axis, and yes, put it to the right. Perfect. And something went wrong. Right, left, right, bottom. Ah, it's probably this. So this is left. This is the top. So it should be left. Actually, let's keep it left, right, top, bottom always. So this is the one that is right. Left, right, top, bottom. Let's try again. Okay, perfect. So, our first tile set. Anyway, select the number of colors, choose the number of colors. We have these very ugly colors, but whatever. Create a unique tile design. So design unique textures or patterns. We're gonna skip that because we're just gonna use this basic coloring. Assign edge colors, sure. And the colors should be chosen so adjacent tiles can be matched according to the Wang tile rules, i.e. shared edges, sure. And again, we're just gonna do something. I mean, maybe we can just try to take this one, just for compatibility. So actually, let's do that one. Let's make something we call tile set, and let's call it tile set 1. So it's gonna be a Wang tile, and the first one will be green, and then all red. Right, the left, right, top, bottom, so that one is red, that one is red, that one is red. And let's do the next one. So we have left is green, right is red, and top is blue, bottom is blue. And I will fill out the remaining ones. Okay, here we are. So first I defined these so I didn't have to write color dot all the time. And they have white colors over here, but we don't have that. We could do that, but I'm just going to use yellow for now. And then we have a list here of colors, and we want to turn those into a set of tiles. So let's call it colors in this thing. And something like that maybe. Okay. And then I want to do like show tile set, which takes a tile set, and then we'll have a size of 1, and then for, yeah, we're gonna need that one, and then we'll say for tile, in enumerate tile sets, I want to say tile.render, but not plus the size plus a offset equal to, let's say 5% of the size, and then we will do equal of and show, and given all of that, let's say show the tile set 1 and exit. So let's see if we got it correct. And we did not, we have to do this. Okay. Not great. What went wrong? It's very interesting that they are not being offset correctly. Height, size. Is very strange. So at least that is working. What if we say times 2? So that's working as well. Of course, has to be I times that. There we go. And let's actually, just to make it even prettier, let's say row is this, and actually that's the column, and this would be the row. And actually let's do x is equal to this one, but with I, instead of I, we use the column. Instead of I, we use column. And this is just gonna be, yeah, it's gonna be the same, I think. Let's check that it works. It does not work because we have to say x and y. Okay, there we go. And finally, something like this. Okay. So anyway, this one should be that one should be that one should be that one. And to me, it looks like it is all correct. So that's great. There was a print, which we will remove. Okay, so now we have a tile set. And of course you can experiment with this. So we have a tile set, initialize a grid. So explain in a list of using a list of steps how to create a grid for the Wang tiles. Okay, so here we go. Decide on grid dimensions. Choose a data structure, a suitable data structure to represent the grid, two-dimensional list. It's a common choice for representing grids in Python. I don't mind that. So let's make a class, number of columns, number of rows. We do this, and we put a bunch of nones. And then create empty grid. We don't need that. Let's say get tile at self row column. And that seems correct. Okay. That's pretty fine. Let's now also have a render method, which will do all of this. Let's make another one that we call, so first of all, it can be a static method. And we'll just call it init, and it will take exactly. So we make a grid, and then we set it's a bit wasteful to, so let's say if there is a, and then it's none, or rather it's tile set, if tile set is none. What's the problem? There we go. And then it's actually a bit silly to have this method at all. So what I want to do now is, let's make a grid with that tile set 4x4, sure. Let's render it and let's exit. And that did not work. Right, because so what do we want to do here? So maybe I do want this init method anyway. Because what should we do if we have less tiles than we have spaces in the grid? So actually what I'm gonna do is do this one, length of tile set. I think that's all right. And we have to use that method down here. So grid.init. Okay. So now we can make a 4x4 grid and place some stuff in there. But this is not what we want to do, as you can see. Actually, let's put also a boundary around the tiles. How do we do that? Is there something like border color? There doesn't seem to be. So we can loop through all the corners and let me do that. Okay, so here's some quick code to make an outline. And why should it be the? So here we go. I just enumerated the corners again, which probably there's a way to condense this. Like here it could just be indices into the corners instead of, yeah, but for now it's fine. So let's see what happens when we run that. Now we get some nice outlines, which lets us see easily that, for example, here is a mismatch, here is a mismatch, there's a bunch of mismatches. Anyway, so now we have created, no, sorry, we're up here. Create a tile set, initialize the grid, implement a placement function. So let's do that. What I think we should do is like place. Let's say try placed tile, and it will be self. It will be a position, and it will be a tile. And then we want to say, yeah, we want to look at the neighbors, look at occupied neighbors, check whether there is any rotation the tile that matches all the neighbors. And I think we should do it like in a way that's agnostic about the order of us placing things. So let's take the left neighbor. Actually, instead of these checks here all the time, maybe I want to put them here. So let's say if row exactly okay, because then we don't need these checks. Check top neighbor. And there's probably something wrong here. How do we render it? Yeah, so the higher the row is, the more up it is. So actually the top is this one. Okay. So actually there's something else wrong here. So we've checked all of these, and actually okay, so there will be like a set of rotations that matches. So let's say candidate rotations is candidate tiles, and then actually let's change the rotate so it makes a copy. Maybe not. Let's make a new function that's called rotations, which will take self and return a list of exactly like that. So candidate tiles is the tile.rotations, and then I want a method that filters out so basically maybe let's say filter tiles. So it's the candidate tiles, it's on the left tile, and we are looking at the left side of the candidates. And this function doesn't exist yet. And then we want to say if the length of the candidate tiles is 0, then we return false. And then we need to repeat this down here. And actually, let's instead do this. So we have a neighbor at, that's the left neighbor. We have a neighbor at 1, and that's the right neighbor. We have a neighbor here, and that's the top neighbor. And we have one here, and that's the bottom neighbor. And we'll say for neighbor in neighbors, neighbor tile is, get that tile. If it's not none, then we will filter, and then we have found a valid tile. So we don't want to set the tile, we just want to like choose a random tile from candidate tiles. And now I want to use numpy and say, so choice is numpy.random choice, I'm pretty sure it's called. And maybe we can do this. Okay, so this is a simple algorithm. So one thing we probably want to do later, here in step 7, write a function that checks whether the target placed is specific. Yeah, so actually this should probably return the list of possible placements, because then in the tiling algorithm we can implement some kind of backtracking. So we need this filter tiles, and it takes candidates, neighbor, and the side. So let's say filter tiles, candidates, neighbor, and the side, and that's it. So now let's make an empty grid that is can be 5 by 5, and it shouldn't be in it, it should just be like that. And then let's say let's do the columns first. So we'll do like this. Grid the try place. And then we will render it. And let's say we also check on the success, and if not success, then let's break. Actually, then we need the success out here, and I'm missing an S. And there as well. And then we have to say if not success again. So let's try that, and the one we want to place is actually, let's say for tile in tile set 1, Okay, so what are we doing? First we're looping over every row, then we are initializing a success variable, then we're saying for each column, try to place a tile and just take the first tile that works. And that tile is placed in the random rotation of one of the ones that work. And if that succeeds, we break. If none of them succeeded, hold on, this should be false. Actually, there's something wrong here. Right, so this is how it is. So it should be false. Then we try to place all of the columns. Actually, I think we have to also, let's make it a little bit more transparent. Let's call it row success and column success. So if we succeed in placing the column, then it's fine. If we don't succeed in, then this has to be set to false. And if the row didn't succeed, then we break out. So the first one that fails, we just stop. Let's try to run it. And there is nothing. So I want to say print failed. There should, so they all failed. They all succeeded. So let's print success. Or am I doing something wrong? 5 successes. Ah, okay, so it's because so actually that one can be set to true by default. Okay, so now there's just the problem that things are not rendering correctly. So let's say for tile grid dot grid. Still, it's all none. It shows. Shows tile none. What? Ah. No. So is it in the filter tiles? Tile for tile candidates if they start out as none. It's weird. Tile. Ah, it's because rotate doesn't. Let's return. Okay, that should do it. It's printing a lot, don't want to print so much. Where is all those coming from? Okay, so clearly it's not working because that's wrong. So let's go to filter tiles, can match. So if my left side is equal to the right side equal to left, top 0 to bottom, so that should be correct. Should be correct too. Let me try to print placed tile this. Neighbors. It's not going to tell me anything. I don't know. Okay, I think I realized what went wrong, and it is that when we rotate, we forgot to also rotate the colors. And why? The color list, which is a little bit, actually it's not great. Why did I duplicate the data? So let's kill that. Let's say colors self, and it will just be like an iterator like this. Then there's no duplication. We have to find where we so that's less nice. Okay. then this should do it. Let's see if there's anywhere else where we have self.color. No. Okay, so this is the first one, second one, third one. Great, I think it's working now. So let me go up and remove this debugging code. And I forgot to remove this rendering. There we go, finally, now it's working. So great, it's always not always, so it shows an interesting tile here, but it's not that, like it's not doing that many interesting things. So maybe, can I do, is there a shuffle? I think there's a shuffle function. If we start from a random one, each time we get something more interesting. Is that perhaps in place? Okay. This is kind of interesting. All right, let me delete that. Let's try one more time. Because it will always place this as the starting tile. But it also did that when I shuffled, right? Ah, okay, so this is a bit better. It doesn't look good, but it's something. Okay, so now we have a placement function, kind of. So please list the steps needed to develop the tiling algorithm using backtracking. Okay, let's have a look. Understand backtracking. Let's say we've done that. Implement the backtracking function. Arguably, do we really need this? The random placement things seem to work. Maybe I should just copy paste this crap instead. Copy, paste. So sure, we are outside, and I don't want to do this. I want to do like in rows. Isn't that something we have in rows and columns? Yes. And there should be columns. And then for each tile in the tile set, can we place the tile? So then we need something like this. Let's change this to and call it can place tile. And we won't actually place it. We will just return true and the candidate tiles. Then this guy can go down here. So candidate tiles. Now that code should still work. So anyway, then we'll say grid can replace the tile, and if so it's, oops. It is row, column, then tile. And actually, place and then candidates. So, which one do we place? Or maybe the tile set. The tile set should include rotations. So we can say I'm gonna copy paste this now because I just wanna get done rotations and this should work. It's not nice code, but it should work. It's a bit silly to even return that. Let's do that. So if we can place it, then we place it. Get next position. Sure, let's define such a function. So, yeah. So if the column is less than this, then we can increment it. Otherwise, we go one row up. Grid and this, and then if we succeed in tiling the rest, then we return true. Otherwise we reset like that. So that's a backtracking. So let's say tile set with rotations is tile for tile that rotate I times for tile in that for I in that. And then we will say backtrack Wang tiling starting from this, and then we will render it. Then we will simply print this and exit. Should work the same way. There's a bit of a problem. It was way slower, but it worked. Yeah, I think we're actually done now. I'm a bit surprised at how slow the backtracking is. Like, let's skip the rendering and time it again. It takes 2 seconds. And if we don't do that, but we use the random one, it's like half a second. So clearly some optimization to be done here, but I think that's for another video. So I'll see you in the next one.